Hello, sixth graders. We are in our rational numbers unit. Our lesson today is on ordering positive rational numbers. Our learning target that we need to write down is I can compare and order positive rational numbers using conversions. Something for us to just think about here is how would you know which is a larger ratio or a larger amount when given varying fractions, decimals, and percent. So if we had these numbers, they're all in different forms, how would we be able to figure out which was the smaller amount, greater amount, so on and so forth? So some vocab here, we're going to look at the symbols that represent them. So greater than and less than, we have symbols that we use, usually greater than, okay, it opens up towards the larger amount, less than, equal to, we use the equal sign, and then on our number line here, since we're looking at positive numbers, I'm going to start at 0 because it's going to be all numbers above 0. The number line does go in the other direction, into the negatives, and then it continues on. So that can be a way that we figure out where these numbers are. We could plot them on a number line. But the biggest thing is to know these symbols, greater than, less than, equal to, and it always opens, if we had 5 and 7, it would always open towards the bigger number. Okay, so if we are looking here to fill in the blank with these less than, greater than, or equal to signs, we need to make them true. There's some stuff that we have to do in order to be able to compare these. So if we had 4/5 and 7/8, these are different types of fractions, and it would be hard for us to figure out what they are. So something that we would need to do if we're working with fractions is we need to get the denominator to be the same. If we had something like 1/4 compared to 3/4, we would be able to figure out which one's the greater amount. So looking at 5 and 8, I know that they both can go into 40. So if I multiply this by 8, top and bottom, I would have 32 over 40. If I multiply this side by 5 to get them to have the same denominator, that would be 35 over 40, which would then show me that the 7/8 is the larger amount. So the symbol would open up that way. So if you're working with fractions and you want to compare them, we have to get a common denominator, the same bottom number, in order to be able to accurately compare them. Now here we have a decimal and then we have a percent. In this case, we could get them to be the same form. So we could put them both as a percent, or we could put them both as a decimal. Either way, that would help us to compare. So I'm going to turn this 125 thousandths into a percent by moving the decimal 1, 2 to the right. So we would have 12.5%. This would then tell me that that was the greater amount, because 12.5% is more than 10 2/10%. Okay, so whatever you're doing, you have to get them to be the same form. So make them all decimals, percents, or fractions. And if you're making them fractions, they have to have the same denominator. Once you have those, then it's easier to compare. So 5 and 43/100ths. Well, I'm going to turn this 5 2/5 into a decimal, because decimals and percents are the easiest way to compare. If you make something a fraction, you're making yourself have an extra step of finding a common denominator. So if I were to make 5 and 43/100ths into a fraction, I would then need to change the 5 and 2/5. So I know that 2/5 is equal to, if I multiply these by 2, it's equal to 4/10. So that would be 5 and 4/10. Now, if we were to fill in that 100th spot with a 0, I think about money. $5.43 is more than $5.40, so our symbol would open that way. Okay. Next one here, I'm going to zoom in just a little bit. 5/6 compared to 625 thousandths. Okay, so for this one, we got to turn 5/6 into a decimal, and in order to do that, I'm going to need to do some division quick here. 5 goes on the inside, 6 goes into 58 times, which would be 48. That would be a 2, add a 0, goes in there 3 times, which is 18. Looks like we're going to have a repeating decimal. And I know 83 is more than 62, so this was 83 repeated, which means that that's the larger amount. That's the bigger number. 30% compared to 1/3. Well, I know 1/3 is that repeating decimal, 33, which if I then turned that into a percent would be 33%. And I know that that is more than 30%. So we're just getting them to the same form, whatever one you prefer, between decimals, percents, and fractions, and then comparing them from there. 35/100ths compared to 3/8. Again, I'm going to turn 3/8 into a decimal by doing division. 8 goes into 30 3 times, which is 24. Goes into 67 times, which would be 56. 4 goes into 45 times, and then we're done. So 3/8 is 0 and 375 thousandths, which if we look, the 3's are equal. If we were comparing these, the 3's here are equal. And then we go to the next number after, 5 and 7. Well, 7 is the bigger number, so my symbol would go that way. Okay, now we're going to work on, we're putting these in order from least to greatest. And in order to do that, we're going to convert them all to be the same format, either all fractions, decimals, or percents. And again, if you're converting to fractions, then you need to get a common denominator. Once you have them figured out, least to greatest, note that they should be written back in their original form. So you might want to write that down. So 1/4, 2/10, 22%. I'm going to put these all into decimal form. I know 1/4 is equal to 25/100ths. 2/10 is already done. 22%, we move the decimal 2 to the left. 0 and 22/100ths. Now, looking at these 3 numbers, I see that 2/10 is the smallest amount, so that one would go first. We're ordering these least to greatest. Next would be the 22/100ths, but that was 22%, so we would write it 22%. And then the 25/100ths, which is 1/4. Okay, 1 and 2/10, 100%, 8/9. Let's turn these into decimals. Move this 2 to the left, which would just be 1. 8/9, I'm going to need to do some dividing here. 9 goes into 80 8 times, which would be 72. Looks like we're going to end up with a repeating decimal here. Okay. 8 repeated. So our smallest amount on this one would be the 8/9. Next would be the 100%, and then the 1 and 2/10. Just thinking about where these numbers would fall on a number line. Okay. Try these two on your own if you feel ready. So 40% as a decimal would be 4/10. 2 and 4/10 is already done. 4/100ths is done. And then the next one, 4/10. So all I did was change the format of these. Now I can figure out where these numbers fall on the number line. If you look, we have 2 of the same. So those are equal. So it doesn't really matter which one we would put before the other. But our smallest one is right here. So 0 and 4/100ths. And then between the 40% and the 4/10, it doesn't really matter which one you would put first, since they are equal to each other. And then the 2 and 4/10. Okay. Last one, 11/4, 2 and 6/10, 13/5. Okay, so we have some improper fractions here. I'm going to turn those into a mixed number. So I know that 4 goes into 11 twice without going over, so that's my whole number. 4 times 2 is 8. 9, 10, 11, there's 3 left over out of 4, which I know is 2.75, like that. Now 13/5 would be 5 goes into 13 2 times, which is 10, which leaves 3 left over out of 5, which if I were to make this into tenths would be 6/10. So 2 6/10. Now they're all in decimal form, so I can put them in order. So again, we have 2 6/10 that shows up twice, so it doesn't really matter which one we write first. 2 6/10 and then 13/5. Then the next one would be the 11/4, the 2 75/100, and then 3 1/10. So once you have them all to the same form, it's very simple to think about where they fall in the number line. Oops. Okay, which is our last thing right here, is putting these numbers on a number line. So it looks like we're going from 0 to 5, so I'm guessing it's going to be 1, 2, 3, 4. So then in between there would be 1.5. Oops. Just a half. This would be 1.5, 2.5, 3.5, 4.5. All right, so now we just have to figure out where they would fall. So 6/10 is just a little bit more than 5/10, so it's about right here. 3 2/10 is going to be in between 3 and 3.5. Sorry, there we go. 40%, if I were to put that as a decimal, would be like that, which would be just a little bit below the 5/10. And we would label that as 40%. 1/2 would be right here on the decimal, 0.5. Again, I'm labeling them with their original format as well. Now 5/2, this is another improper fraction. The top number is bigger, so we look at the 2. We say 2 goes into 5 twice, which would be 4, with 1/2 left over, which would put us right here for 5/2. And the last one, 24/8. 8 goes into 24 3 times with nothing left over, so that would be right there. Okay, once I turned them all into decimals, it was a lot easier to figure out where they would fall. All right, that is your lesson on ordering positive rational numbers. Go back and rewatch if you are stuck. Otherwise, come with questions tomorrow.